Welcome to part 3. Let's include our geometry. Then change this one to 2D. Double click. Okay, first, please go to your file, Space Claim Options. Go to File Options. Okay. Just make sure your settings is the same as what I have here. Once you're done, just select OK. File. Just select the SolidWorks part just now. Okay. The change in the settings now will allow Space Claim to include the lines here, the separation of the surfaces, so that it will not stitch and merge them together. We need this so that we can use them in ICM. Okay, you can just double check near the trailing edge. Okay, everything seems okay. Now I can just exit. And just call out ICM. Okay, you can just drag ICM, double click to open. Just wait for a few seconds to let it load. Maximize the window. Okay, there you go. So the first step will be to create a naming for each of the curves. First, we'll start with the inlet. Just box select to reduce the number of clicks. Okay, once you're done, you can just hide your inlet. Start with then followed by your outlet. Hide your outlet. Continuing with shell 4. Hide. Then shell 3. Hide. And shell 2. Shell 1. Just going to fast forward the video. Box select whenever you can. And finally, shell 0. Okay. And then we can do the normal lines. Okay. Can hide them. And then we can do for the FY upper. In case you can't locate your leading edge, you can just turn on your normal lines. Just to know your starting point, then you can just turn it off. Okay, the same thing for you can hide them, then change it to lower. Okay, do the same thing, select everything. Okay, and just hide it, then zoom out, and then you can select everything to name it as guide curves. Okay. Then on your inlet, under blocking, the third tab over here, then select the first one to create a block. We are going to name it as fluid, and then change the type to being 2D planar. and apply. Then we can associate 3 edges over here with our inlet, and then the last edge over here to our outlet. Can slide here, the 4th tab over here, then select the 2nd one over here. 1, 2, 3, middle button, and then just box select your inlet, box select your edges, and box select for your outlet. Then now you can turn on your F1 upper and lower. Now we are going to split the block, the 2nd tab over here, and then create an O grid. Select the block here, the 1st row, as well as and then you can select the edge on the 3rd row over here. Okay, apply. Then split, selecting the 1st tab over here. Right at the shiny edge, doesn't need to be perfect. And then you can collapse the block, select the 3rd tab over here, and then as well as the 3rd one over here. Select this edge to this block, block 17. Okay. Can turn on the points. I'm going to associate this vertex over here to this point, as well as this one to this point. Okay. Okay, just split the center. And then add the block, the 4th tab over here, and select the 1st one to combine block 21 and block 4. Click both of them and hit the middle button. Create pipe, name it as solid. And then select the 4th one over here. Okay, select block 4, and that's it. Supposedly, I should have hidden solid, but it's okay. Now, under associate, just associate the points here. And then this one will come here, and this one will come here. Now, the idea is that this one will be attached to the semicircle, and this part here, solid, should be follow the contour of our airfoil. So this one will be attached to the leading edge. This one will be attached to the 1st guide curve in the clockwise position on the top part, and this one on the lower part. Later on, we can split the block again to accommodate the remaining guide curves. Okay. If you can't locate your leading edge, you can just turn on your normal lines. There you go. Do the same thing for your shiny edge. Okay. Now turn your guide curves. See, this one will be your 1st guide curve, 2nd, and 3rd for the top part. So this one will be attached to the 1st guide curve on your airfoil. There you go. Do the same thing for the low surface. Okay, turn off your points, and turn off your guide curves as well as your normal lines. Okay. Now, these two edges here will define your upper surface. And these two edges over here will define your lower surface. Now I can just associate. I will turn off the F4 lower. Okay, select these two edges. I will hide the edges. And then I can just box select everything because I don't want to individually click all the curves here. It will take a lot of time. So just a shortcut. There you go. Do the same thing for the low surface. 1, 2, select. Turn off the edges. Turn on your curve. Only for the lower. Then just box select. Okay. Notice that once the edges are associated, it will turn green. Those that have not been associated yet is in light blue. So actually, this one is will define our airfoil. This one are just straight lines for now, but it will eventually follow the guide curves after associating it. Okay, now, like I mentioned just now, this one after associating to the first guide curve, you will follow the contour. Now we need to split the block so that we can introduce another edge for the top and lower part to follow these guide curves. Okay, now we're going to split the block. Okay, second tab. Okay, I'm going to split it. Then turn on your points. You can immediately associate the points. Okay, do the same thing for the third guide curve. Then associate the points. Okay. Then just zoom out. We can easily see that this one should be here, this one should be there, so on and so forth. Now notice that we have another line, another curve that goes through here that will relax the mesh. So we're going to do another split over here. Okay. Then associate points. Now we are done with our guide curves. We can start splitting for our shells. Split. Try to adjust so that the edges here is approximately close to these points. It's not necessary, but it will help you to estimate which vertex should go to which point. See, now it's easier. Try to be systematic to avoid mistakes. One edge at a time for each top and bottom surface. Okay, top, bottom, top, bottom, yeah, like that. Top, bottom, leading edge. Okay. Do the same thing for your shell 3. Okay. Just gonna fast forward. Shell 2. Then shell 1. Okay. Now we can go to the outlet. That's very easy to locate which vertex goes to which point. Okay. Now it's starting to look like our SolidWorks design. Okay, now under this blocking tab over here, we need to select index control. Now it will be, this one will be introduced. Okay, we can play around with the final row of the points. Up until shell 1. I can turn on my normal lines, turn on a curve, so as the points. Okay, now why did I do this? Because when you're splitting in ICM, it will only split what is visible on the screen. I don't want to design too much guide curves. I need a lot of normal lines, but I don't need a lot of guide curves. So the idea is that I'm just going to split on the first shell, and I don't need to do a lot of clickings and associating for lots of guide curves. So this is the reason why I need to hide all the other blocks and only show these blocks here. I can just split only what is visible on the screen. Okay, just try to locate your, oops, I think I'm gonna hide my solid right now, and then just hide the blocks. Yeah. Okay, split. Just to locate accordingly. And just associate the edges to its corresponding, it's a vertex to its corresponding points. Okay, we're just gonna fast forward. Do the same thing throughout the F1. Split and then associate the points. The number of number lines is depending on the F1 curvature. If you think that less is enough, then be my guest. But if you want it to be very well defined, you can add more points. But then again, you need to do more work in splitting and then also designing in SolidWorks. Okay. Same thing, split and associate. I just did one near the leading edge and another midway just to ease the process so that every time when I split, it's easier to locate without doing any mistakes. Okay, associate the points. Oops. Okay. Okay, just reset the blocking. Okay. I can use the index control to only show the edges that are intersecting with the fourth shell. Okay. This is an easy way so that I don't need to do a lot of clickings to associate shell 4. Yeah, I can turn everything off except for fluid, geom 1 and shell 4. Okay, just select everything and then select all curves. There you go. Now select shell 3, you can just increase, play with the index control and repeat the same procedure. It's confusing at first playing around with the index control, but you'll get used to it. And it's very helpful. Okay, finally for shell 0, okay, I can just reset. Notice that everything which has been associated is turned green except for the blue ones here. Just turn on guide curves. Select the near the weight region because it's a straight line, so it's easy to just associate everything in one go. For this one, 1, 2, 3, 4, hit the button. 1, 2, 3, 4, hit the button. Repeat the same thing. 1, 2, 3, 4, 1, 2, 3, 4. Okay. I can turn off the guide curves. Now everything is in green except for the normal lines, but it's okay because it's just a straight line. So you'll just follow the contour. Now it's time to set the number of nodes. So if you're interested to use K-Magus ST or the transition model, you need a y-pass value of 1. You can just estimate this one using this website. I'm just going to copy paste. Remember to select copy parameters. Select that one. And remember to use geometric 2. You see that the arrow is pointing inwards, right? So this is 1 and this is 2. So our y plus value should be starting from this point. So this will be as named as spacing 2. So our y plus should be filled here, spacing 2. So it was 6.1 to the minus 6. And then it is best for you to just play around with the nodes, just increase it, and then just look at your ratio to what's the value. See, every time you will increase the number of nodes, this one will change. So you can just try to get it around 1.1 or 1.2. It's up to you. Now it's 1.2. Now it's 1.1426. Now it's 1.1. 35 nodes. Now you can select this one here, the fourth tab, mesh edge spacing. So whatever you have over here will automatically be the same spacing for the starting for this edge over here. So it will grow, it will transition smoothly. Okay, now I can select this one here, the third one. Remember that since just now we selected copy parameters, right? So since we have shared the spacing from the biggest one here from this edge to the starting for this edge, it will be the same throughout all parallel edges. So you don't need to do for each and every one of them. Okay. See, now your spacing 2 is being filled automatically. Now change to geometric 2 and just play around with your nodes so that the ratio is about 1.1 or 1.2. It's up to you. Okay, this one was 1.07, still okay. As long as it's not too big. And remember to match the edge as you go away from the F1. See, mesh edges, then you set a number of nodes. Change to geometric 2, increase number of nodes until you get a ratio 2 of your desire. Match, set number of nodes. Geometric 2, increase number of nodes. Now it's 1.12. Just make it 40, 1.09. Okay, that's good enough. Now we are done with the number of nodes going away from the F1. Now along the chord length, I'm just going to estimate it to be 6. But I'm focusing here. Now the spacing is 00032. I'm just going to increase the number of nodes so that it will be almost the same as 00032. Okay, 4 seems okay. 00022. So I'm going to change this one to 00022. Now it's 00024. That's okay. Now it's 00023. Yeah, that's also okay. It doesn't need to be perfect. It's okay. If it's 4, then it's 00018. It's okay. triple 019, triple 019, triple 019, 4 as you go, triple 018, just triple 022, triple 023, triple 020, okay, now we can match the edges. Just now it was triple 0.2 something. We just increase so that this value here is approaching triple 0.2. Okay, with 25 nodes, we're going to get triple 0.24. So since the spacing is the same for the top and bottom, we're just going to do 25 for all of them. 25, 25, 25. I think there's a faster way to do it, but you can just share with me if you know in the comment sections. Okay, and then match the edge from the trailing edge to the wake region here, and then select it, and then use geometric 1. Okay. See the spacing is being preset. Just increase number of nodes to what you feel fit. About 30, I'm going to get a ratio of 1.16. What about 36 nodes? 40, 1.1. That seems okay because near the airfall, the way is there's a lot of interesting things happening. So we need a lot of nodes over there. Same thing here, we need geometric 1. Okay, just increase the number of nodes. 40 seems okay. And just turn off the edges and start the pre-mesh. Just like yes. Yeah, there you go. I think there's a problem near the wake region. Like this is most likely is an association problem. So we're just going to turn off the pre-mesh. And I think this is the problem here, this edge. What you can do is that go to this tab here and then dissociate from geometry, just like this one. Now it's blue, right? Try to pre-mesh again. There might be some association problem earlier, but now it's okay. It looks nice. Okay. Okay, you can see that there's a big jump over here. It's not that important actually, because what's important is whatever that is close to the airfoil. But we can fix this. And turn on the edges, turn off your pre-mesh. Now the idea is that we need to make the spacing from this point here, from this edge, to be equal to the first spacing on this edge. So you're just going to match the spacing value. Same thing here. So for the higher concentration to the lower concentration. Okay, turn off your pre-mesh. Okay, first thing, turn off your copy parameters. Remember that. Okay, match spacing, high concentration to lower concentration, high concentration to lower concentration. Okay, do the same thing for the next shell. High concentration, low concentration, same thing. Okay. Then what you can do next is that since this starting of the spacing here has been changed, we can make it grow more gradually. So the ratio can be about 1.05, something like this. We'll see. Right now it's just to 1.05. Do the same thing over there. Notice that the direction is upwards, right? So this is 1, this is 2. Just now we matched the spacing from this high concentration to this low concentration. So this is at ratio 2. So you change over here under ratio 2. 1.05. Apply. Here, see? Now this one is going upwards, right? So this is 1, this is 2. So we just match the spacing from this point, from this edge to this edge. So you must change about on ratio 1 here. 1 point, we can make it bigger. We don't need to make it 1.05 since it's going further, right? So we can make it about 1.1 or 1.08. Yeah, we're going to use 1.08. And same thing over there. Now we're changing at ratio 2, 1.08. Okay, apply. Now we can turn off the edges, we can pre-mesh. See, now it's growing much more gradually, right? From high concentration to lower concentration. Okay. Everything's growing smoothly. The mesh is following the guide curves, and the mesh near the airfoil is normal. So supposedly it should be okay. Now we have the number of cores of 140,000. Yes, it is a lot, but depending on your application, say if you're using Kmegas ST, you don't need this. You may not need this amount of mesh density, but if you're using a transition model or something like this, you may need better resolution. You just convert to unstructured mesh, then output mesh, like the first one. Your solver setup is MSys Fluent, then you can change your boundary condition. Your airfoil is lower, set it as wall. Same thing for your airfoil upper. All the guide curves, shells, and whatnot, normalize, you're just going to set it as interior. It means that it's just won't affect the calculation. Okay, inlet as well as the inlet, normalize as interior. Outlet as pressure outlet. Shell 1 up to shell 4 gonna be interior. Okay, and just accept. And save as. Yes. Open. Don't forget to save it as 2D, and you're done. Okay, I hope that you enjoyed the video. Thank you.